All right, welcome to our study of limits. We're going to do a lot with limits next year with calculus, so we want to get a head start here. Repetition is key to learning. Why study limits? Limits helps us understand what's happening to numbers around points. It helps us with understanding continuity, so on and so forth. All right, so I'm going to just go ahead and dive in here. So when we look at number 1, we have f of x is equal to 3x minus 6, and I'm graphing it. And graphing is very important because we want to study what's happening to our at our point coming from both sides. That's going to be one of the big things that we're really going to focus on in lesson 2. Okay, so we want to make sure that we're graphing so that we can see what is occurring. And again, like I said a second ago, it's about what's happening around points. So when I look at f of x and I talk about x approaching 3, so when I look at my graph, 3 is right here, and so I'm going to look and see what's happening from both sides as it is approaching 3. And it looks as though it's approaching a y value of 3, so therefore the limit of f of x as x approaches 3 is 3. All right, so when I look at when it is approaching a negative 2, then I look at negative 2 and I see what's happening all the way down here. And as I can see, it looks like it's approaching a negative 12. And I'll explain how I was able to come up with that value in a second. And then when I look at as x approaches 0, well, we all know that x is equal to 0 on the y-axis. So as it approaches the y-axis from both sides, it looks like it is approaching a negative 6. So therefore, the limit is negative 6. All right. So algebraically, some of you are probably just saying, well, f of 3 is equal to 3 times 3 minus 6, or f of 3 is equal to 3. And that f of negative 2 is equal to 3 times negative 2 minus 6, and that f of negative 2 is equal to negative 12, and therefore f of 0 following the same thing is negative 6. So we can just kind of plug our values in. And when it's a continuous function like you're seeing here, yes, that does work. But again, I do want to caution you, you do need to make sure you study graphs. All right. So on to example number 2. If I look at the limits as x approaches 5, so 2, 3, 4, it looks like 5, and it looks like it's approaching a y value of 1, so I would say the limit is 1. If I plug that in, 5 minus 4 is 1, square root of 1 is 1. The limit as f of x approaches 4, well, it looks like that 4 would be right here, so it looks like it's approaching 0. Okay, and then as x approaches 0, well, that's all the way over here, and the graph, doesn't exist. So we're going to say D and E, that the limit does not exist. All right, so be careful with that one. That might come up later on. Think about situations in which, it doesn't exist. Fractions pops into mind when the denominator ends up equaling 0. That's when you can get it does not exist. All right, third example. So I graphed h of x equal to 3 to the x power. So as x approaches 2, okay, so 2 is over here. If I were to plug that in, 3 squared, I would get a 9. As x approaches 0, 3 to the 0 power would be 1. And as x approaches negative 2, that's occurring right here. It looks like it is at 1/9. Okay, example 4. So here's one that has a fraction, and it looks like we got two things that we have to be careful of. So just finishing off this graph here, it looks like when x is equal to a negative 3, you have 4. So you've got this point over here, and looking at this, x can't be negative 3, so therefore we've got a hole occurring down here. All right, so this is something that we might have to pay attention to. All right, so the limit as x approaches 0, it looks like we're going to get a negative 3. The limit as x approaches 3 looks like it is 0. and then the limit as x approaches -3. All right, so some of you might say, oh, it's 4, but it's not 4 because we want to study what is happening as x approaches -3. So looking at our graph, it looks as though it is approaching a -5. Okay, so you have to pay attention to where is, sorry, it should be -5, -6. I apologize. You have to pay attention to where it is in terms of this graph and where it is approaching. Okay, some of you might also look at this and say, oh, x squared minus 9 is x minus 3, x plus 3, x plus 3 cancels. Okay, remember that's when you end up with a whole. A whole occurs at -3. And so now if I plug my -3 in here, -3 minus 3 is -6. Okay, so that's our study of limits. And like I said, make sure you understand the importance of graphs because that's going to come into play in lesson 2.